Hello everybody and welcome to this new course, Xage Zero Trust Blockchain Protected Fabric for IIoT. I'm happy that you are here. In this course, I will try to explain the Xage fabric. I will start with foundations and architecture, and then from the next lesson we will right away start the installation of the Xage fabric and then start doing the labs after that. Maybe in the middle we will have a short lesson about the GUI to just explain the menus of the Xage interface. It's very simple and intuitive, so it will be a short lesson, and just after that lesson we will do multiple labs to cover most of the use cases of the Xage fabric. So without any delay, let's jump into the foundations and architecture. So first of all, guys, we would like to talk about a very common terminology in the ICS or industrial control environments, which is called the distributed control systems. Actually, this codes are just extracted from a very nice documentation by NIST, the special publication 800-82R2. I put the link for it here. It explains the distributed control systems in the industrial control environments. So basically, before reading these codes, let's have a look about a typical DCS implementation. So basically, guys, this is the enterprise, okay, and the outside world connected to the internet, for example. So you have here the IT engineers managing their enterprise. They have workstations, printers, application servers, and so on and so forth. Okay, so the industrial control environment has its own specifics, as you can see here. So the DCS model is actually explaining this. The DCS model is a distributed control environment or systems where you have two layers mainly: the supervisory level or the supervisory layer, where you put some systems to supervise the field level or the field layer, which contains the actual actuators, the actual sensors that are doing the work. So for example, if you have an oil refinery, you have a water waste planet or something like this, so you have some sensors, some actuators that are doing the work, some valves that are doing the work, and these actuators or these sensors, these motors, this hardware are managed by some controllers in the field called programmable logic controllers, PLCs. So in the field level or the bottom level of the industrial control network, you have the PLCs and the actual physical valves or sensors or actuators. And there is a level for monitoring or supervising, which is called the supervisory level. This one contains some common terminologies like engineering workstation, like a normal PC for that has some software installed to manage these PLCs and to send commands, for example, to increase the volt or to reduce some level of power. There is data historians that have log for what is happening in this supervisory level. There is HMIs, there is control servers, all of this in the supervisory level, and these supervisory systems are actually managing multiple subordinates or multiple subcomponents, okay? And maybe in the middle there is a WAN or radio network, or based on the case. Some oil refineries are in the desert or in the sea, so there should be some WAN connectivity to them, and the supervisory level may be in another place. So this is just a high level diagram for how things are working. And between the supervisory level and the enterprise, commonly there is some DMZ or demilitarized zone to separate them from each other. So basically this is what is explained here, that the DCS are used to control the production systems within the same geographic location for industries such as oil refineries and wastewater treatment. So you have production systems here, you have this supervisory level to control this production systems. So the DCS are integrated as a control architecture containing a supervisory level of control overseeing multiple integrated subsystems that are responsible for controlling the details of a localized process. There is a localized process here in site A, there is a localized process here in site B and in site C, and all of them are sharing the same set of commands which are set or sent by the supervisory level. There is some loop back to send some feedbacks about the measures, for example. So the engineering workstation can send or set some commands to set the levels to the right levels. A DCS uses a centralized supervisory control loop to mediate a group of localized controllers. Here the controllers, we mean the BLCs, that share the overall tasks of carrying out an entire production process to accomplish the desired product and or process tolerance around a specific set point. Specific process controllers or more capable BLCs are employed in the field and are tuned to provide the desired tolerance as well as the rate of self-correction during process upsets. This is not our course, actually. I'm just trying to give you guys the feeling about the ICS environments and how they interface with the enterprise. So at the end of the day, we as an IT guys here, normally we are all coming from IT background. We need to have also a control and visibility on what's going on here. So actually we interface with the supervisory level because these guys can speak the common TCP/IP Ethernet protocol language, and we can know what is going on. But actually these guys, like the engineering workstation, like the data historian or the HMI, or these guys are speaking a different language, different protocols, industrial control protocols like Modbus and DNB3, and there are specific industrial protocols that the IT cannot actually speak. So there is no direct communication between the enterprise and the OT or the ICS world. Okay, so I encourage you guys to check out this PDF. It's very interesting and have more explanation about this. But this is a good start to give us an idea about what is the problem we have here, and then we will then understand the value of Xage here. The problem that we have here, as we said, we don't have a very good control of the security of this environment. Actually, these guys are using non-standard protocols, and these protocols are normally designed with no security in mind, because the whole intention of the industrial control systems is to operate and do the operation very good and very fast. So they don't care at the beginning when they designed their protocols about security. Security was not in mind or not in the design at the beginning. So the only way or the best way to actually protect this environment is to secure the access to this environment. So we need a very robust way or a fabric or a framework to access this OT environment or ICS environment without actually compromising this critical infrastructure. Okay guys, so now we have the DCS understanding. This is an example of one of the ICS protocols, the Modbus protocol. You can read here guys that it's a communication protocol originally designed to be used with the Modicons PLCs, and over the time become a de facto standard communication protocol for industrial electronic devices. Today, Modbus can be seen as a common way of connecting a plant system supervisory computer with a remote terminal unit in supervisory control and data acquisition systems in industrial automation solutions. So the SCADA systems is sitting here, and there is a communication with some RTUs or some terminal units or some valves or some PLCs. All of this is happening through the Modbus protocol. Okay, and the source of this information is from clarify.io. Okay, now a very well recognized framework that is used in the ICS networks called the Bordeaux model. The Bordeaux model is a framework used in the ICS networks that segments devices and equipment into hierarchical functions. If we recall from this diagram, you can see here by design for any infrastructure or enterprise network or connecting to ICS network, the functions are different, so they should be actually grouped or layered in different categories or in different levels, and this is what is actually said, or the whole purpose of the Bordeaux model is to group the functions separately from each other. Okay, so this is the reference for this quote. The model, the Bordeaux model, uses the concept of levels in order to subdivide the enterprise and the ICS. So here we subdivide the enterprise and the ICS segments into functions that are that have a similar way of doing the work. Okay guys, so this is a Bordeaux model example. This is my drawing actually. I hope you like it. So you can imagine we have here level 4/5, like the enterprise IT segment, where we have here our Exchange or mail server, our application servers, the Active Directory, all our IT stuff here. Okay, and then there is a DMZ segment, okay, between the enterprise and the OT or the ICS, the supervisory and the field level. So assume this is the supervisory level, we call it the OT segment. It occupies level 2/3, and the field level, which occupies level 1 and level 0. Okay, and there is a DMZ, the like level 3.5. So basically we have level 4/5 the enterprise IT, level 3.5 the DMZ segment, level 2/3 the OT segment, or that contains also the supervisory level, and the field levels, the level 1 the PLCs, the PLCs, and then the level 0 the sensors, the actuators, the valves, and so on. So basically guys, this is the Bordeaux model in action, but without the Xage fabric in place. And we can spot from here that there is multiple ways we can compromise the OT and the ICS environment, because the typical way of accessing the remote access is through a VPN to some firewall, and from there you can have the access to the engineering workstation, and all the flows are allowed on the firewalls, and the firewall is not something we can rely on for the security of critical resources like the engineering workstation. So any attacker coming from the internet can actually install some Trojan or some malware on the engineering workstation, and then this can compromise the whole ICS network. So relying on firewalls or even jump boxes like some PC that you terminate on and then connect to the engineering workstation is not also so secure. And this actually brings the Xage unique capabilities and use cases. So Xage actually, guys, specialized in the zero trust approach for access management for the critical infrastructure, including the operational technology, OT, IoT, IIoT, industrial IoT, you name it, to serve basically three key use cases. So the first use case is zero trust, secure local access for floor operations within the OT infrastructure itself. So this guy will not be provided with physical access to the engineering workstation, but he has to come through Xage Fabric, as we will see shortly. Okay, securely facilitate vendor and third-party OEM remote access into the critical infrastructure down to the OT devices, the level 1 devices, the PLCs and the RTUs. So these vendors will not actually have a VPN and just once they connected through VPN they are as if they are inside the environment. No, they will be properly managed to access the critical infrastructure in very secure way. So this is the second use case. The third use case is the enabling the dynamic data security to secure the sharing of events and data streams from the OT devices to any external entity without exposing those IT systems to any other network. So basically, sometimes we need to collect some metadata from our PLCs and some information from our supervisory level to the external world, to some monitoring system in the enterprise IT like SIM solution or any other monitoring solution. So to leak this data from the OT, we need a very secure way to actually do this task. And even if we want to send some information from the enterprise to this guys, this critical infrastructure, we need also a secure way. So the data exchange between this sensitive critical infrastructure and the outside is also one use case that you can achieve with the Xage. So all the sessions will always be terminated within the OT infrastructure itself to achieve that. So actually with Xage we will have termination points on the Xage Fabric itself, so the outside world will not be able to communicate directly with the ICS infrastructure, not like the case of the VPN. Once you are here, you are having, or once you are connected to the VPN here, you have full connectivity based on the firewall rules, which can be misconfigured, and you can have access and install whatever you want. No, we will have the Xage Fabric in place to terminate the sessions, as we will see shortly, to just reduce the risk to zero. Let's say zero trust. We have the zero trust model to achieve that. Okay, so one may say, is it an IAM solution, identity access management solution? It's basically, guys, three different products in one single fabric platform. So the first product is identity based access management. So it's the zero trust here is not based on segmentation like the typical, or the, let's say, the classic zero trust models is to have multiple zones in your network and separate the zones and classify the zones. This is critical zone, this is medium critical, this is sensitive, and then you design your firewall rules if you are coming from untrust to trust, or from confidential to less confidential. You have the rule allow, if you the other way around is not allowed. This is the classic way of managing zero trust. But here with Xage, the zero trust is actually identity centric. So it's identity based access management. Yes, this is one product inside the fabric. The other product is the zero trust remote access. As we saw here, as we mentioned here, that we will ensure the this users accessing the critical infrastructure, we will handle them based on zero trust approach. The zero trust data security, as I explained, we can leak some information from the critical infrastructure in secure way through a producer consumer approach, as we will explain shortly. Okay, so these are three products in one platform. Is it also a PAM solution? Yes, it does privilege access management. It basically allows you to integrate with Active Directory and create user accounts with specific privileges to target critical devices. So I can have a policy that allow me to access this engineering workstation in read-only mode, for example, or full control, to access it with read-write control. So this is also doable with the Xage fabric. So you can create user accounts with specific privileges to target critical devices, where the Xage fabric will be the interface for accessing those critical devices. So you will always terminate on the Xage fabric before accessing these critical devices. And we will see actually how you are accessing. You are accessing in very controlled way. All the critical devices credentials will not be exposed to the user. It will be closely managed by the fabric. So it's a PAM solution. You are not exposed with the credentials. Actually, as we will see in the labs, you will just land on the Xage box or the Xage fabric, and from there you will find the resources that you can click and stream the connection to these resources. So actually the connection will be handled on the Xage fabric itself through a reverse proxy, so you are not having a full access on the critical infrastructure at all, and you are not aware of what is the credential being used actually to access this infrastructure component. So you are not exposed to the credentials. So it's a PAM solution. For example, integrating with AD, Active Directory, enabling and disabling accounts. This is the functions of a PAM solution. Rotating the password after every access attempt. So we have the option to generate a random password like OTP every time you are accessing the engineering workstation. So this is a typical PAM functionality. So every time I access one, the Xage fabric will generate a one-time password that grant me the access, and I can even control the time of the session. I can record the session. I can collaborate with someone else. So for example, Hatim is the vendor, Ahmed is the customer. So Ahmed can access the engineering workstation and then invite Hatim to through session collaboration to join, and I can control the transaction of Ahmed separately from Hatim transaction. So Ahmed would be granted a full control over the engineering workstation, read-write access, while Hatem will just be invited in read-only mode. So this is the zero trust approach we are talking about here. It's identity centric, so every transaction is being treated separately and only satisfied or allowed based on the policies defined within the Xage fabric. It includes functionality not only for the standard protocols. For sure, the Xage fabric supports the standard Ethernet protocols, the standard TCP/IP protocols, but it's also extended to the industrial protocols, including Modbus, DNP3, and any other proprietary protocols used in your OT infrastructure. Okay guys, so let's go now. This is actually the last slide, and I will take like 10 to 15 minutes speaking here in this slide, because this is the core of the Xage fabric. So basically guys, it's the same diagram that I used here without Xage, but here we remove these firewalls. Actually you can have them still, but I just wanted to focus on the Xage fabric, and I put the Xage fabric everywhere we needed to have a very secure access either locally or remotely to the critical resources. So you can see here one Xage box here, one Xage box. So all these blue boxes are Xage. Okay, so 1, 2, 3, 4, 5, 6. So actually Xage fabric guys is a distributed architecture. It's actually an immutable ledger. So if you know guys about blockchain, the blockchain is a very modern concept in the security space, where you have a distributed decentralized immutable ledger. You know guys, the ledger concept is a finance concept where you have a record, a physical record. Actually the accountants are recording every transaction, like every financial transaction in or out of the corporate. So they are recording in a ledger, and these ledgers are then used to construct the accounts and the balance sheets and this kind of stuff. So in the blockchain we have a digital ledger. Actually the immutable ledger, immutable means the integrity of the blockchain is never compromised. Anything written to the blockchain cannot be changed by any means. In the same fashion, in the financial world, anything written in the financial ledgers cannot be changed, and this actually contribute to the financial records, and here also this contribute to the records of the infrastructure of the blockchain. So we cannot change anything in the blockchain ledger. It's a very robust architecture where we don't have a single appliance or a single VM. We have multiple VMs, as you can see here. Okay, so the Xage can is actually installed on VMs. Only this component called ZEP, we'll talk about it, the Xage enforcement point, is a hardware. Okay, so it's a special hardware sold by the Xage vendor. You purchase these ZEPs and then you install the Xage software on it. So basically to achieve this distributed ledger, the Xage utilizes multiple nodes, as you can see, and the ledger is established between them. So the blockchain concept is achieved by a consensus approach. So all the boxes are contributing in the calculations of for example, to construct any credential or anything, there should be a consensus process among all these guys. No one can take the decision on its own. So let's say we have 1, 2, 3, 4, 5, 6. So more than 4, like 3 plus 1, needs to agree on the construction of this credential. So it's almost impossible to compromise the Xage fabric. So the Xage understand actually the OT network is micro-segmented based on the board model. So that's why we deploy a node in every critical segment. So you can see here we have a Xage IT node in the IT segment. We have a Xage OT DMZ segment node in the DMZ segment, the 3.5 level. We have a Xage OT node in site A, for example. If we have site B, because the plants, like for example oil refineries, you may have multiple plants in multiple locations, so you will need actually OT node, Xage OT node in each plant. Okay, and finally the zips. The zips actually, guys, are a hardware that you purchase from Xage, as I said before, and it is actually positioned in line between the OT level 2 devices like the engineering workstations and the level 1 controllers, the PLCs, just to restrict the access from the engineering workstation to a specific PLC to that remote user account. So for example, Ahmed or Hatem, the vendor, has access to the engineering workstation. So if the zip is not there, so since Hatem has the access to the engineering workstation, he would be able to access the SCADA back or the Fisher Rock. But the zip is providing an extra layer of enforcement to actually restrict this, or to have a granular policy enforcement to just allow Hatem, for example, to access the SCADA but not the Fisher Rock. I hope this clears the value of the zip here as an extra layer of protection, and I will stop here to not make that video so long. And actually in the next lesson I will detail the Xage protection with some scenarios for access, and also we will speak about other capabilities of the Xage in more detail. Thanks guys for watching, and see you in next video.